Sometimes it makes sense to add and subtract numbers written as percents, and sometimes it just doesn't. When does it make sense, and how do we make sense of it? So let me give you an example first where it definitely doesn't make sense to add percents. At a certain boys' basketball team tryout, 100% of those trying out were boys, and 100% of those trying out liked playing basketball. So 200% of those trying out were boys who liked basketball. This is clearly dumb, right? This is clearly not the case. It does not make sense to add this 100% to this 100%. The first thing we have to make sure of before we go around adding and subtracting percents is we have to make sure that the parts don't overlap, right? The 100% who were boys were also the same 100% who liked playing basketball. What if I said 100% of those trying out for the boys' basketball team were boys, and 100% of those trying out for the boys' football team were boys? So 200% of those trying out for either team were boys. Again, clearly dumb. Why? Because they're percents of different bases. In order for adding or subtracting percents to make sense, we also need to have the same base. Okay, so those are the two big examples where adding percents just don't make any sense. If the parts overlap, or if we have different bases. Let's see an example. Now let's see an example where adding and subtracting percents does make sense, and see exactly what it means when we do that. So suppose that in a class with 25 students, 4 of them, 16% of the class, got A's. 6 of them, 24% of the class, got B's. 7 of them, 28% of the class, got C's. 5 of them, 20% of the class, got D's. And the last 3, 12% of the class, got F's. And suppose we want to figure out what percent passed with an A, a B, or a C. What should we do? Well, we've got a couple of options, right? Our first option is we could just figure out how many students passed with an A, B, or C, and then figure out what percent of the 25 that is. And that may be the most obvious option. So we had 4 A's, 6 B's, and 7 C's. 4 plus 6 is 10, plus 7 is 17. And then 17 out of 25 is what percent? We cross multiply. 17 times 100 is 25 times x. 1700 is 25 times x. What times 25 gives me 1700 is the same question as what is 1700 divided by 25. So we'll write out that division. 25 doesn't go into 17, it goes into 170, 25, 50, 75, 100. 125, 150, so 6 times. Into 200, 25, 50, 75, 100. 125, 150, 175, 200. So 8 times. So the answer, 68% passed. But maybe there's an easier way. This 17 out of 25, that was the 4 out of 25, plus the 6 out of 25, plus the 7 out of 25. Right? Of course, that adds up to 17/25, thinking of these as fractions. But the story told me that 4 out of 25, that was 16%, 16 out of 100. The 6 out of 25, that was 24%, 24 out of 100. The 7 out of 25, that was 28%, that was 28 out of 100. What happens if I add together 16 plus 24 plus 28? 6 and 4 is 10, and 8 is 8. 1 and 1 is 2, 4, 6. I'll get 68 out of 100. That is, by adding 16% plus 24% plus 28%, I get 68%, which is the same answer I found here, without having to solve a proportion. Why does this work? Notice, this is the fraction of the class that got an A. This is the same amount expressed as a percent. This is the fraction that got a B, same amount expressed as a percent. Fraction that got a C, same amount expressed as a percent. So when we add up the fractions, that's the same as adding up the percents. And adding up the fractions, well, that's the same as adding up their numerators. So just adding up the size of each part and then putting it over the whole. Why did this make sense? The bases were the same. In this case, the whole class. And the parts didn't overlap. So nobody got at the same time both an A and a B. So we could just add them all up. And whenever we can just add them all up, we can also just add up the percents.